Hello out there. The purpose of today's video is to look at how to simplify radical expressions. It's not really something that is practical in mathematics anymore, but it's one of those skills that is useful if you're going to continue to study mathematics. It's important for your mathematical fluency and understanding of the properties. So, deal. But, for example, if you had the square root of 50, we should learn to recognize that that has a perfect square within it. In this case, it's 25 times 2. So 25 is a perfect square, 2 is not. So 50 can be broken up into 25 times 2, therefore the square root of 50 is equal to the square root of 25 times 2. Now the property that works here, it's called the product rule for radicals, and it essentially means that the square root of a product is equal to the product of the square roots. In other words, you can take the square roots separately and then multiply the result, or you can multiply together and then take the square root. So each of these is true, that's why I'm using equal sign to express this much. Before I go any further, I would like to explore a side note. Notice my clever sideways note. A lot of times students will misappropriate the product rule for radicals over here to talk about the square root of a binomial. If you have 25 plus 2, not 25 times 2, and you have the square root, a lot of students are inclined to say that that's equal to the square root of 25 plus the square root of 2. That is completely untrue. There's lots of reasons why. I might have discussed it in class, but for you, make sure all of you understand that is on the order of puppy killer status. So do not apply the radical property called the product rule. Do not apply that to sums or differences, only to products. That's why they call it the product rule. So one example I wanted to look at is 216, and we need to break that into perfect squares and not perfect squares. Now, depending on your numeracy abilities, it may be difficult to determine what are the perfect squares in 216. So there's a side skill, and this is an option. You can choose this option or not, but if you're stuck and you don't know where the perfect squares are, then this is a safety valve for you. All you have to do is take the number 216, and if it's even, just divide out a 2. It goes in 108 times. Then you find out how many 2's go in 108. That'd be 54. That's still even, so I'm going to go 2 more. That gives me 27. And that's not even anymore, but I know a 3 goes in there, and that's 9, and that's 2 more 3's. So my next step is to look for pairs of numbers that will make perfect squares. 2 times 2 is 4. 3 times 3 is 9. So I'm going to group together all the pairs and get 4 times 9, which is equal to 36. Then I'm going to group together all the non-pairs, the lonely boys, and we have 2 and 3 here. That's going to be 2 times 3 is 6. So the number 216 can be broken up into 36, the perfect square stuff, and 6, the non-perfect square. So how did I do that again? I took all the pairs of numbers and multiplied them all together to get a perfect square, and all the non-pairs were the leftovers. So that's something that you don't necessarily have to write out, although you can and should to support your work and to support your thinking. Some people can do this mentally, however, so I'm not going to force you. However, if you have wrong answers and you didn't try to use this technique, then I'll have to blame you for intellectual laziness. Nonetheless, I take the 216, and now I can break it up into 36 times 6 square root. And then I would like you to show this step every time because I need you to reinforce the nature of the property. The property says the square root of a product is equal to the product of the square roots. If you say that in your head every time, it'll hopefully reinforce that rule as well. Square root of 36 is 6, so instead of the square root of 36, I write 6, and then here I have the square root of 6 as a leftover. I forgot to mention something about checking your answers. I wanted to go back real quick here. We've got square root of 50 is equal to 5 square root of 2. You can use Desmos or any calculator. Notice I type in the square root of 50. It gives me a decimal approximation. If I type in 5 times the square root of 2, it gives me the exact same decimal approximation. So there's no excuse for getting wrong answers here. The only thing that you should do to check that a calculator can't check for you is to make sure the number that's left over is, in fact, completely simplified. I'll give you an example of what I mean. A lot of times when people are asked to find the square root of 32, they would say, well, that's easy. That's 4 times 8. And they would take the square root of that. And then they would take the square root of 4 times the square root of 8. And they would get 2 square root of 8. Now, that is in fact mathematically true. 2 square root of 8 is equal to the square root of 32. However, it's not completely simplified because 8 still has a factor of 4 in it. So you could either continue to simplify, or you can start over from 32 and just say, oh yeah, silly, that's 16 times 2. And that's a little bit more direct path. Anyway, one last example. Sometimes you might have a number times a radical, and just to make sure you all understand, it's all multiplication. It's 5 times the square root of 45, which is 5 times the square root of 9 times 5. Break up the radical, so the square root of a product is equal to the product of the square roots. That's 5 times the square root of 9 times the square root of 5, or 5 times 3 times the square root of 5. And the 5 and 3 can multiply now to make 15 square roots of 5. Once again, don't forget to check in the calculator. There's no excuse for having wrong answers. You could make mistakes in your product, in your factoring. That's okay, as long as you catch those mistakes when you use the technology to check. So thanks for watching, you guys. Have a great day.